what do you guys remember from yesterday? Cosecant of x is equal to what? 1 over sine x. And it works both ways. Sine is 1 over cosecant. Okay, what about secant x equals 1 over cosine x? And then what was equal to sine over cosine? Tangent. Okay, so the top two, those are a couple of reciprocal identities. These are what we call quotient identities. What happens when you flip sine and cosine? You get cotangent x. Okay, and that was all yesterday. All right, now, when you multiply two reciprocals, this is what we were just talking about, sine times cosecant, that you get a 1, basically like a canceling. What about cosine times secant? 1, tangent times cotangent, 1. Okay, so I want you up here in this space to go ahead and draw your hexagon again. I want you to get in the habit of drawing it. It doesn't have to be perfect. It's just there to kind of help you with some of these identities. I want you to write a big 1 in the middle there. And does anybody remember what we started up here? What trig did we write up here? Sine. So sine x, and then cosine x, then tangent x, and cotangent. Down at the bottom was secant x and cosecant x. So every day we're going to draw this hexagon. I want to kind of remind you of why this works. The diagonals, when you multiply them, you get 1. That's why we have a big 1 in the middle. That's one reason. Okay? If you start with tangent and you go either direction, tangent is sine divided by cosine. Tangent is secant divided by cosecant. You can do the same thing with cotangent. Cotangent is cosine divided by sine, and it is cosecant divided by secant. This is a way to help you remember the identities when you're not having your notes right there. You can come up with your own identities. So we're going to add to those with some things called Pythagorean identities. What does the word Pythagorean sound like? Pythagorean Theorem. A squared plus B squared equals C squared. You've been doing this since junior high. Okay, so we start with Pythagorean Theorem. X squared plus Y squared equals R squared. So look at this right over here. We saw a picture like this when we started doing exact values. Okay, the horizontal distance is an X because it's along the X-axis. The vertical distance is Y because it's along the Y-axis. And what does R stand for? If this was a circle, a radius, okay? And so we have our little angle down here, our reference angle. And so we know that x squared plus y squared equals r squared. Okay, look what they did in step 2. We divided both sides by r squared. So on the right, r squared divided by r squared becomes a 1. Okay, now think about it like this. Cosine. What's the ratio for cosine? Using SOHCAHTOA. Adjacent over hypotenuse. X over r. So what we're going to do is we're going to replace x squared over r squared with cosine squared. And likewise, y is opposite, and we're going to replace y squared over r squared with sine squared. Now, if you are like, I don't totally understand how you came up with that, that's okay. In the end, this is another identity you're going to have to know. It comes from SOHCAHTOA. Now, this right here is how we typically see it with x's. When we're doing trig proofs, we could be using any letter, but the letter we're going to use most of the time is an x. All right, I want to show you this real quick up here in our trig circle, or trig, not circle, hexagon. Okay, I want you to kind of lightly shade in that top triangle. Okay, now watch this. The upper left squared plus the upper right squared equals the lower squared. Sine squared plus cosine squared equals 1 squared. And what is 1 squared? 1. Okay, so that's how you can read the hexagon to figure out that identity. If you forget it. Okay, now there's two other ones.
I don't know if I understand like this hexagon thing.
It's just a way to help you remember the identities. So like, and I'm going to go over it a little bit every day. As of today, you don't have the identities memorized, and that's okay. We still got plenty of time. We still got like almost a week to work on that. Okay, so we have 3 Pythagorean identities. Okay, and what happens is, see how this first one, it starts off just like normal. Sine squared plus cosine squared equals 1. And what did they divide by each thing? Cosine squared. So then we use our trig identities. Sine divided by cosine, that's tangent. So sine squared divided by cosine squared, that's tangent squared. Cosine squared divided by cosine squared, you divide something by itself, you get a 1. And remember, 1 over cosine, that's a secant. So this right here is another Pythagorean identity. And I'm going to just go ahead and circle this one over here. I really don't want to spend a lot of time explaining how we get the identities. It's great if you understand that. However, in the end, I really want you using this hexagon. So watch what I'm going to kind of make it to where we can see these two and up here. So I want you to shade in this triangle and this triangle. So see how we've shaded in, and it kind of almost looks like a nuclear symbol. If you are on your phone in this exact moment, you need to put your phone in your backpack. It's obviously distracting you, like in your backpack. Do you want me to call your name out while I'm recording this for everybody to hear? Because I will. Okay. I'm just trying to be friendly here. All right, so remember how before I said sine squared plus cosine squared equals 1? Well, it works with this triangle as well. Tan squared plus 1 equals secant squared. Hold that thought. That's what this says right down here. Okay, look right here. 1 plus cotan squared equals cosecant squared. That's what this says. So the whole point of the trig hexagon is so that you have your identities there, but you've got to make sure that you're using it. Okay, so what I would like for you to do, well, real quick, before we move on to the next page, let's actually do what the notes say. Write 6 expressions that are equivalent to 1. Well, we already have one. Let's go ahead and write down the easy one. Sine squared x plus cosine squared x, that equals 1. That's 1. So how many more do we need to write? We need to write 5 more. Okay, now see this one, how it says tan squared x plus 1 equals secant squared x? How could I get the 1 by itself?
Secant squared x minus tan.
Perfect. Secant squared x minus tan squared x. And let's see if we can do something similar to this other Pythagorean identity. If we wanted to get the 1 by itself, we would need to do, right. So the whole reason we're doing this is because in the future, you might see one of these things, and what can you replace it with? A 1. And a 1 is really simple, and we like 1. Okay, now that's only 3. We need 3 more. So was there anything else that we already did? Maybe multiply 2 things, that got us a 1. Yep, so give me one example of that. So sine x times cosecant x. Those 2 things are reciprocals. You multiply them together, you get a 1. Okay, I'll start the second one. Cosine x times secant x. Tangent x times cotangent x. And this is why there's a big 1 in our trig hexagon. You can't see it now, but it's up at the top of your paper so that it can kind of help us with that. So what I would like to do is to turn the page. And over here in the little, you're going to have a kind of a blank space over here. I want to draw the trig hexagon again. I know you're like, but we just had it. I could flip over and look at it. The more you draw this, the more you're going to know how to draw it. You're going to get better at drawing it, and it's going to help you with these problems. So you start just by drawing the hexagon, and then you're going to label like where the things go. So we have a sine x, and I'm just going to do it. I'm not going to say it. You can copy it from here. So by the time we take the quiz, you should be able to draw this by yourself. What did we put in the middle? A 1. So let's put a big 1, and I'm going to circle it. You don't have to, but let's put a 1 in the middle, and let's lightly shade these 3. It tells us what the new Pythagorean identities are. So for the 3 shaded triangles, I know that sine squared plus cosine squared equals 1. For this one, tan squared plus 1 equals secant squared. And 1 plus cotan squared equals cosecant squared. Okay? For the other one, those are the only 3 Pythagorean identities, unless you want to like move stuff around, but it doesn't work for the other triangles. Okay, so let's look at this example 2. Which of the following is not equivalent to cosine squared? All right, so let's start with this one. 1 minus sine squared. Okay, think about our identity here. We have an identity that says sine squared x plus cosine squared x equals 1. So answer choice A says 1 minus sine squared. Is that cosine squared? Yes, that is cosine squared. So that's not our answer, because we're looking for the one that is not equivalent. Okay, before we do these 3 in the middle, let's skip over to E really quick, because E is actually really similar. What about sine squared x minus 1? Like, if we look at our identity, and I subtract the 1 over here, what would I have to do to the cosine squared? Subtract it to the other side. So what is sine squared x equal 1 equal? Negative cosine squared x. So what does that tell us? That's our answer. Just for fun, let's go through the others. Because isn't that y'all's idea of fun? Okay, so let's look at the others. Cotan x. Okay, I already see a secant and a cosecant, so let's kind of keep with that. What is cotangent x equal in terms of secant and cosecant? If you forget, look right here. Find cotangent and go in the direction. Cotangent equals cosecant x over secant x. So I am going to replace this with a cosecant x over a secant x. Other cotangent?
There's another.
You know what? Write it. You just said that made me think it would be easier to write the other cotangent. I know that's not what you were asking, but I wasn't done. I just wasn't done yet on that one. Let's go the other direction. I'm going to show y'all why here, because it didn't look like some things were going to cancel, and that's just kind of the process of these problems. If I go this other direction and I replace cotangent with cosine x over sine x, and then let's write down what was already in the denominator. I'm replacing cotangent x with what it equals. One of our identities was cotangent x equals cosine x over sine x divided. So it's basically like I've replaced the one circled thing with the new circled thing. Okay, so do you see anything in the denominator that might multiply to a 1? Almost. Sine and cosecant. That makes a 1. Those are reciprocals. Now I have a cosine on top and I have a secant in the denominator. Okay, a secant in the denominator, if I wanted to move it to the numerator, I would need to make it into, like, watch what I'm going to do here. I'm going to move secant to the numerator by, like, dividing it or taking the reciprocal. And what's the reciprocal of secant again? Cosine, right? So you can move that secant x to the numerator by changing it into a cosine. And what's cosine times cosine? Cosine squared. Okay, that's another cosine squared x. We already know this was not our answer. Okay, we were looking for the one that is not equivalent. We already found it. Remember, we're just doing this for fun. Ha ha, right? Okay. Is out of the two that are left, is there one that you think you understand how to make it into cosine squared? Look at D. 1 over secant squared x. What is 1 over secant again? It's cosine. 1 divided by. When you guys see 1 divided by, you need to think reciprocal. This is going to help a lot of you a lot. So when you see 1 divided by secant, think reciprocal of secant. And that's cosine. And since there's a squared, we just put a squared there. And so that's not my answer. And this one I should cross off too. So I have C left. Now C is kind of hard to prove. We already know the answer. And so we know this one has to turn into cosine squared. Okay. I'm not going to make y'all go through this process right now. We already know what our answer is. We could do some more, but I want to kind of get into the proofs and maybe we'll come back to that one. Okay. So let's look at example 3. Practice writing trig proofs. We've already practiced this a little bit. When they tell you to transform this, you have to start with this one. So one thing that I want to get us in the habit of doing is underlining what we start with. Okay? Because in a little bit, like meaning next week, I'm going to let you choose which one you start with. So I want you to go ahead and underline that. And by underlining it, you don't have to write it again. So algebraically, how do I break this up? Double distribute. So 1 times 1, that's going to be 1. 1 times negative cosine A is negative cosine A. Okay, then I have cosine A times 1. That's a positive cosine A. And it's okay that we're using A instead of X. It's fine. And then the last one would be cosine A times negative cosine A. What would that be? Negative cosine A squared. And so the way we show squared is to put the squared in between cosine and A. That is signaling that we're squaring the whole thing. Okay, so all I did was algebraically double distribute. Now, do you see anything that's going to cancel? The negative cosine A and positive cosine A. It's not because I'm multiplying, it's because you're adding and subtracting the same thing. So what would I replace that with? Like, what is negative something plus itself? 0. Okay, so that's why that cancels. Okay, so let me go ahead and write what we have left. 1 minus cosine squared A. All right, when you start seeing this, you need to think Pythagorean identity. Let's look at our trig hexagon. Sine squared plus cosine squared equals 1. So what does 1 minus cosine squared equal? Sine squared. And isn't that what I was trying to prove it equal to? So I put a check, a smiley face, whatever you want to put there. We move on to the next problem. You don't have to. It is a nice way to just kind of know that you finished it. Because otherwise it's like, it kind of just like, oh yeah, we're done, I guess. Okay, so let's look at this next one. Again, let's get in the habit of underlining the side we're going to start with. And then that way you don't have to rewrite it. You could rewrite it. And then look at what I'm trying to transform. I have in the problem I start with a cosine squared and a sine squared, but then in the end I don't have a cosine squared. So what we're going to do is we're going to replace cosine squared with something. Okay, now remember, sine squared x plus cosine squared x equals 1. So what does just cosine squared x equal? 1 minus sine squared. Maybe, I'm thinking maybe just for now, let's go ahead and write this identity down here and let's talk this out one more time. So that's the main Pythagorean identity. If I want to just get cosine squared x by itself, do you guys see how we just subtract over sine squared? Okay, so I'm going to replace cosine squared with 1 minus sine squared x. And then I already have another minus sine squared x. So let's just write that one, only because it was already there. Okay, on this one, I don't see things that are canceling. I see things that are combining. Yeah, I have a minus sine squared and another minus sine squared. So in total, I have 2 sine squareds. And that is exactly what we were trying to prove it equaled. So I'm done. It's weird. Embrace the weirdness. You will see. Right now, we just need to practice the skill. We're not ready to apply this yet. Okay, let's look at C. Transform cosine m minus secant m squared. So again, let's underline the side that we're going to start with. And in the end, I should get this other thing. So when you see something in parentheses squared, are we allowed to just square the first thing and then square the second thing? We got to write it twice. This is just good algebra skills. So some of you have been missing algebra. This is a good algebra skill right here. And there's an m here instead of x, and that's okay. We will have an x most of the time, and then sometimes we'll have a different letter. Okay, so this is kind of like the first one. We have something in parentheses times something in parentheses. We need to double distribute. Okay, so I need to do cosine m times cosine m. So that's something times itself. So I would write that as cosine squared m. You want to put the squared in between the cosine and the m. That's just the way we're supposed to write it. It's a conventional way of writing that. Okay, now I need to multiply the other one. Cosine m times negative secant m. So watch what I'm going to do here. Minus cosine m times secant m. That is going to make a 1, and I'm going to do that in my next step. Okay, now I'm ready to distribute the negative secant m. So negative secant m times cosine m. And then what would be the very last thing we write? So first of all, a negative times a negative would be a positive. So positive secant squared m. Okay, so I already heard a couple of you saying, don't those things cancel? Well, they do. Watch what happens here. Cosine times secant, as long as that letter's the same, is a 1. I have to write the minus 1 here because it's not being multiplied to anything. So I can't go, oh, it's implied times 1. You got to actually write that 1. Okay, same thing here. Secant times cosine, that's another minus 1. Yes?
I don't understand why you can't, okay, so unknown is home with the minus 1, but since there's 2 of them, why don't you just cross out the cosines and cross out the secant?
I'm not multiplying them to each other. Like this is, these two are being multiplied to each other,
Yeah.
and then these two are being multiplied to each other, but it's not, it's a minus 1 and then another minus 1.
I know, it makes no sense.
Well, I mean, keep asking questions because it actually does make sense. We just need to get it to make sense. So if you had in a problem 1/2 times 2, what does that equal? It equals 1. Essentially, that's exactly what I'm doing, but just with more complicated things. So it's like having a minus 1/2 times 2. So I have to multiply these two things to get its own 1. So in place of cosine times secant, it's a 1, and over here, it's another 1. But I have to do them separately. I think that's what you're asking. Okay. So now I'm kind of getting a little bit what I want, and I'm going to erase this just so we can see what we're trying to get to. It looks like I need to get rid of one of these 1s and a cosine and replace it with either tan squared or sine squared, and I need to do the same thing with the other. So if we look back at our trig hexagon, I think it would be helpful here, especially since this is early, for us to go ahead and write these other identities. So using this identity down here, let's go ahead and write that down. The more times you write this down, the more times it's going to be like something that you're used to, you're more comfortable with. So tan squared plus 1 equals secant squared. Likewise, 1 plus cotangent squared x equals cosecant squared x. Okay, I want to focus in on this little piece right here first. If we had this top identity and I did cosine squared m minus 1, what would that equal? It would be sine, but we'd have to move the sign to the other side. So this little piece right here is equal to negative sine squared m. Now, here's a little trick about trig proofs. I'm not ever asking you, is it equal to the end? I'm telling you. So look what's in the end. It's a minus sine squared m. So even if you weren't sure, that's what you have to end up with. Okay? So sometimes it's kind of like a little bit of BSing your work to get your answer. You can do that. That actually works well here. Okay? Teacher approved. Okay? You still got to show the steps, but if you're like, is it sine squared or is it negative sine squared? Well, it has to be negative sine squared, right? Because that's what's in the final answer. Okay, so let's look at this piece over here. Now this says negative 1 plus secant squared. All right, look at what we have in this identity right here. If tan squared x plus 1 is secant squared, if I subtract over the 1, isn't that just like having a negative 1? So that has to equal tan squared. And you know what? I have a tan squared here, so it has to equal it. Now, I have written them in the reverse order. So what would be great is to just go ahead and make sure we flip it around so that it looks exactly like what they told us to make it look like. So this one was a step up from some of the other ones that we've done. It's the first one we did like that. So if you're like, this is hard, that's okay. It's not supposed to be easy, all right? You just have to kind of endure through it. All right, let's do one more. Okay, transform tan x plus cotan x into something else. So we're going to start with this. Now, I see a plus sign here, and I don't see a plus sign in what I'm trying to get it to equal. So this tells me that I'm supposed to do something with adding fractions, common denominator. That's not something we've done yet either. So, is there something I can replace tangent x with? I can replace it with either sine divided by cosine or secant divided by cosecant. And you could do either one. So you want to pick secant and cosecant because that's what we have over here. I think that's probably a good idea. We can make this work actually either way. Okay, what can we replace cotangent with? Okay, I'm going to go with what you guys are saying. I will tell you, if in the end, if we're like, we should have used the other one, we're going to find out and we can always go back and change it. All right, or it could be that both ways work equally. All right, I don't want to just, y'all can just copy down what I do, but it really won't help you if we don't kind of think through it together. Now, if you're going to add two fractions, what has to be true about their denominator? It has to be the same. And these are not the same. So I'm going to make bigger fraction, and I am going to make my denominator the multiple of both of these. So I'm going to change the denominator to both of them. This is exactly what you do when you multiply by fractions or add fractions anyway, when they're just numbers. So in the first group, I changed the denominator. What did I multiply the denominator by? Sine. I have to do that to the top. So I have a secant x times a sine x. Okay, over here, I already had a cosine x in the numerator. What did I multiply the denominator by? Cosecant x, so I'm going to do that up here. All right, now that you have the same denominator, you can combine these two. We're going to run out of time. So this is where we are going to run out of time before I have enough time to explain this. So I'm actually going to stop here. We are kind of getting to where what we have isn't really super helpful for what we want to go. Okay, so what I wanted to kind of explain, we're not done, you don't need to pack up yet, but I just want to take this moment. When you get to a place like this in one of these proofs, you're like, I'm actually getting further away from what I want to do. Because although what I can do is multiply cosecant times sine, that's great, but can I do a whole lot with the top? So remember back to when I said, okay, we can definitely replace cotangent with this, but we may find that that's not what we wanted to do. And that's not a bad journey to go on. If I just tell you what to write, you'll write it down and you'll be good for that problem, but it will, in the long term, not help you in the process. Okay, I wish we had about 5 more minutes, but we don't. So we're going to write TBD on this, and we're going to continue this later, okay?
To be continued.
Yeah, I should write a C, right? To be continued, not to be determined. We already know what it's going to equal. Have that